All right, so we'll start with number one. Let me just get something set up here. Okay, this says assume that 12 jurors are randomly selected from a population in which 60 or 73% of the population are Mexican Americans. Refer to the probability distribution table below and find the indicated probabilities. So this is the number of Mexicans that could be selected in the jury, and this is the percentage of that specific outcome. So there is a 0.1255 chance that the jury will contain 7 Mexican Americans. So this says find the probability of exactly 8 Mexican Americans. Well, that would just be this box, 0.2122. Okay, find the probability of 8 or fewer. So I'm just going to take that box and add up all the boxes above it. These 0 pluses just mean it's possible, but it's so close to 0, we just say 0. So we can add them up. So we have, look at that, 0.2122 plus 0.1255 plus 0.0542 plus 0.0172 plus 0.004 come on 0.004 plus 0.0007 plus 0.0001. That should do it. So we get 0.4139. So it says, does the occurrence of 8 Mexican Americans among 12 jurors suggest that the selection process discriminates against Mexican Americans? No, because it's almost 50%. Right? If you, no, it would be 50%. It's pretty high, 41.39%. It's high. When you have a low probability, that's when you want to say no. I'm sorry, say yes, that there is discrimination. All right. So now this is for a group of 40-year-old men. The probability distribution for the number X who lived through the next year is given in the table below. So we have 0, the chance that 0 will live another year, 1 will live another year, 2 will live another year, 3 will live another year, or all 4 will live another year. So when it asks you to find the distribution mean from a table like this, you're going to put this into your calculator. I'm going to go to Stat, edit the list, and I'm going to go, let's see here, up. I'm going to clear out L2, enter, and clear out L1. So I'm just going to put all the outputs into L1. 0, 1. Stupid. 1, 2, 3, 4. And their respective probabilities on L2. Okay. Now, once you have that, I'm going to go back to Stat. I'm going to hit the Calculate list, and I'm going to do one variable statistics. So my list is L1. That's the different outcomes. Frequency lists is the probability or frequencies, and I'm going to calculate. This is the same thing as finding the expected value. Okay, but they just want the mean, which is the top number, X bar, which is going to be 1 decimal place, 4.0. 3.96 rounds to 4.0. keep moving. So it says tickets for raffle cost $16. There were 762 tickets. One ticket was randomly selected, and that person wins $1,000, and also is given back the cost of the ticket. For someone who buys a ticket, what is the expected value? So whenever I have expected value problems, I just start by drawing this chart here. It's going to be 3 vertical lines, and then a horizontal line for each of the outcomes. There's only 2 outcomes here. So then I'll label this in the following way. The first column is going to be, let me get out of this, is going to be outcome. The payout, the probability, and then we're going to multiply. So the outcomes here, either you win or you lose. If you lose the $16 you paid for the ticket. So that's going to be a negative 16. If you win, you get the $1,000 plus the $16 you paid for the ticket. So really, this doesn't mean anything to the winner. They're just going to get the $1,000. This will be a payout of $1,000. Right? If you bought a $2 lottery ticket and you won $20, you really only won 18. But if I give you back the $2, then you actually just won $20. So the probability that you win, there's 762 tickets. So the chance that you have the winning ticket is 1 over 762, which means the probability you lose is 761 over 762. Now we'll just multiply. This is going to be 1,000 over 762. And this is going to be negative 16 times 761, negative 12,176 over 762. Then you can just add this multiply column up and get your final answer. 1,000 divided by 762 plus negative 12176 divided by 762. So we expect to lose $14.67 every time you play. Sometimes you'll win, but most times you'll lose. So on average, you'll lose a little more than $14 every single time. All right, and 21 says assume the procedure yields a binomial distribution with n equals 31 trials, and the probability of success for one trial is p equals 0.27. Find the mean for the binomial distribution. If you go to our Blackboard page and click on our Blackboard page and go to course materials, down at the bottom is there something called the formula reference sheet. I think it's extra additional resources, and then formula reference sheet. So this could look like this. So we're looking at the binomial distributions on the left-hand side. Make this a little bigger. Here's how you find the mean and sigma for a binomial distribution. So this is just going to be the mean mu is just going to be 31 times p, 0.27. That's 8.37. One decimal place would be 8.4. Find the standard deviation. So that's going to be sigma is the square root of n times p. Oops, n times, doesn't really matter. N times q times p, n times p times q, same thing. So the first thing I'll do is say square root button. It's right there. N is 31 times p, 0.27 times q, which is just 1 minus P. So if P is 0.27, then Q is going to be 0.73. Mouse pad sucks. All right. And it wants it to 2 decimal places, so 2.47. So it says use the range rule of thumb to find the minimum usable value. So we're just going to do mu minus 2 theta, and then mu plus 2 theta. So the first one, we'll take 8.4 minus 2 times 2.47. That's our lower. So I'll just do it, 3.46. And now I can add this, grab this, and add a plus sign there. 13.34. And there you go, brackets with a comma. And there's the questions.